Okay, so recording is in progress. So why are we here? Okay, so basically we are here to utilize the summer effectively. So 10th grade to 11th grade is a substantial jump. And IB definitely, IBHL, the two AA is on the higher side of the difficulty, right? So we want to use the summer to bridge that gap a little bit. I see one other person joining, Ahana. Okay. Ahana is Nidhi's daughter, right, Ahana? Or am I confusing with someone else?
Yeah.
Okay, then who's Lily? Ahana, can you turn on your video, please? Okay, so I mean, if you're not ready yet, you can do so in about 5 minutes, but I would like to see everyone's faces. I read a lot from your faces. So whether you understood something or you didn't understand, based on your expression, that tells me a lot of story. Okay, so basically we are here to do a boot camp. The name boot camp because we'll be doing in a very short period of time. We'll try to cover a lot. That said, I won't be rushing or anything, right? Then it's pointless. I'll be going at a brisk pace. And the expectation from you guys is, since it's summertime and you don't have too much going on, you'll be able to keep up and put in decent amount of effort during the week and then catch up. Okay. Obviously, I'll have to find a middle ground. Some of you might have done something like, for example, Avya has done international, whereas you guys have not done. Ahana, what about you? What did you do in 10th grade? Extended or international or IG or ICSE? Which one did you do? Avya just cannot stop laughing. What's up? Okay. Maybe, you're on mute. Maybe you're saying something.
So I didn't realize I was muted. So.
Okay. All right. You can finish.
No, so I won't laugh now.
No. I like cheerful faces, but if there's a joke, do share.
No. So nothing. I won't laugh.
Okay. No, please. I don't want people to have very strict faces. I want you guys to have fun, right? The last thing I want to do is have a very strict class and you have to be cheerful to grasp things, right? So anyway, back to Ahana. Ahana, what did you do in 10th grade? ICSE or IG?
I did ICSE.
ICSE. Okay, cool. So the topics are fairly overlapping. There are a few here and there. So the whole point of this boot camp is also to serve as a bridge course, because there'll be a few topics in ICSE which is not done in IG, even international math, and then vice versa also. So get everyone on the same level field. So I had proposed a couple of topics. Well, for today's class is just a mock class or a demo class, right? So I had proposed maybe quadratics, logarithms, and trigonometry, a sample of all of this, right? So we'll obviously do these topics in great length, but I could as well do something else if you guys have a preference for something. Sumair, what is your preference among the topics? What is it that you like or dislike? It could be either way, right? You would want to do something that you don't like or don't have a good hang of that you would want to benefit.
So I'm not really that familiar with the IB math, so I'm not really sure.
Forget about IB math. From what you have done at 10th grade level, like any particular topic or topics which was little hazy or not very clear.
Not really, so I think they were
not really. All good. Okay. Have you guys done logarithms in school?
Yes, sir, but just a little bit.
Just
we haven't
basics.
gone too much in depth.
Okay, so maybe we can do. Yeah.
Logarithms. I didn't do logarithms.
You did not do logarithms. Okay.
Even
so,
I didn't do logarithms.
Ahan, what did you say? I'm sorry.
Even I didn't do logarithms.
You did not do logarithms. Okay, maybe that's a good topic for us to do, and Sumair as well, probably, right? Because you are also doing the same.
Yes, sir. So, but I know a little bit of the brief.
Little bit of the basic. Okay, so fine. So before we go into logarithms, we need to understand exponentiation. Exponentiation. Ahana, if you're comfortable, you can turn on your video, but do so in some time at least. Okay, so again, just so that, for example, if you're talking or asking some question and you're muted, I wouldn't even know that you are muted. Plus, as I was saying, right, I infer a lot from the questions you ask and the expressions that you make, whether you understood something or not. Okay, all good? Okay, so we'll start with logarithms. Are you able to see my screen, guys? Not yet, because it's a strict question. I was not sharing yet. Now I'm sharing. Avya, able to see this?
Yes, sir.
Okay, all good, right? Okay.
I just need to pick up a call. Could you give me 1 second? I'm home alone. I just need to pick up a call.
Oh, sure. Okay. Come back. Okay. I'll just get started with basics, Ahana. So don't worry. I'm sure you know this. Okay. So before we get into logarithms, so I'll just say the topic for today is, one of the topics for today is logarithms. Okay. Also called logs for short. Okay. Now, it's just an inverse process. It's an inverse process of exponentiation. Okay, so my handwriting will be clumsy, but as long as you're able to follow along, that's all I care about. All right, exponentiation. Okay, all right. So inverse process of exponentiation. So what do I mean by that? So first of all, why do we have exponentiation? So back in like second grade, we just did 2 plus 2 plus 2 plus 2, right? And we kept writing, and then we said it's 8. And then we learned we don't have to write so much. We can write it in one go as 2 times 4. Ahana, announce yourself in your back so that I know. Okay, so 2 times 4 is 8. So we invented, or rather, whoever the math guys, invented this symbol called multiplication, which is repeated addition. So multiplication is repeated addition, right? Because it's clumsy to do, like, if you have to write 2 plus 2 30 times, it's much easier to say 2 times 30. Now the same can be extended for multiplication as well. So suppose I do 3 times 3 times 3 times 3 times 3 times 3, right? It's so much to write. I might as well write it as 3 power 6. So exponentiation, right, is repeated multiplication. So you can see the analogy, right? Just like multiplication is to addition, the same relation, exponentiation to multiplication. So it's one more level of finding a shorter way to avoid the long-winded, right, multiplication, right? So it's a power b. So far you guys know this, right? Now, so we understand exponentiation. Now, what do I mean by the inverse of exponentiation? It's like the same analogy that you have with multiplication and division. For example, if I have 4 times, I don't know, 7 is 28. That's one way to write. Another way to write the same thing is 28 divided by 7 equal to 4, right? So these are equivalent ways of writing. Multiplication and division are just inverses. Exactly the same way, the exponentiation and logarithms are inverses of each other. I'll give one example, then you'll understand. So 2 power 5. So what is 2 power 5, Sumer?
Oh, so 2 power 5 is 32.
32, yeah. So powers of 2, powers of 3, perfect squares, perfect cubes, all of these you should be like, you should know them, how shall I say it, off the cuff, right? At least till 1000. So all the perfects, I don't mean 79 square, I mean perfect squares which are less than 1000, perfect cubes which are less than 1000. Perfect cubes are only 10 of them, right? 1, 8, 27 and so far and so on. And similarly, perfect squares, the highest perfect square is 31 square. 32 square goes beyond 1000. So perfect squares, perfect cubes, powers of 2, powers of 3, these are all very basic things you should know. So, and 2 power 5, here's a milestone. 2 power 5 is 32, 2 power 10 is 1024, right? So anyway, we'll come to that. So 2 power 5 is 32. Now, how do I write this equivalently in terms of logs? So I will say, I'll introduce this word called log. So I will say to reach 32, so log of 32, I'll write this first and then I'll explain. So it's a little weird when you see it for the first time. So this is asking the question, to have to reach 32, I must multiply 2 by itself how many times? So form that sentence in your mind and then this will make sense. So to reach 32, so look at the level in which this is written. So log and 32 are written at the same level. At a level below that, the number 2 is written. So this is not to be read as 2 power 32. So it's to be read as log of 32 to the base 2. Okay, some people, while telling it fast, they read it as log 2 to the 32. Don't do that. Try to say in this sequence. So I'll just put it, try to say log first, and then go to 32, and then go to 2, and then reach the answer 5. You should say log of 32 to the base 2 is 5. Okay, does it make sense? Okay, so Ahan, so what is log of 81 to the base 3?
So log.
By the same logic, log 81 to the base 3. Okay, Sumer, you want to try?
It'd be 5. Yeah, no 4.
It's 4. Yeah.
4, right? Yeah. Sorry, you said 5 and then you corrected to 4, right, Ahan?
Yes.
Yeah. So 3 needs to be multiplied by itself only 4 times. 3 times 3 times 3 times 3 is 9 times 9, which is 81. Right? It's log of 81 to the base 3 is 4. Okay. And you can work with reciprocals as well. So Ahana, you want to tell me what log of 1 by 8 to the base 1 by 2 is?
3.
3. Exactly. So 1 by 2 times 1 by 2 times 1 by 2 is 1 by 8. As simple as that. Okay. So good job. Avya, what is log of 5 to the base 25?
So 1 by 2.
1 by 2. Very good. So slightly tricky. So log of 25 to the base 5, we all get it. I mean, for at least for the people who are doing for the first time, it's tricky. Otherwise, it's straightforward. Log of 25 to the base 5, all of us know it's 2, because 5 needs to be raised to the second power to reach 25. Log of 5 to the base 25 is asking the reverse question, right? So it's just the reciprocal of this. So why is that? So for example, suppose I didn't know that, in fact, I'll say this. If I have log of, I won't even keep 25. Let me keep log of 31 to the base, I don't know, 17. Okay. So if this number is X, then log of 17 to the base 31 will just be the reciprocal. Why is that? Let's understand why this is the case. Okay. So suppose, okay. So what do I mean by this statement? Log of 31 to the base 17 is X. So what do I mean by that? If I have to write it in terms of exponentiation, it's 17 needs to be raised to the power X. Obviously, X is not a integer or something. It would be some 1 point something, right? Because 17 power 1 is 17. 17 power 2 is a big number, 289. So 17 power maybe 1.2 or something will be 31. I'm just making up some number, but it'll be some number between 1 and 2, closer to 1. Are you guys able to feel that the number X will be between 1 and 2 and closer to 1? Sumer? Yeah? Okay. So 17 power X is 31, but we need to answer not this question. We need to answer 31 power what will be 17. That's what we need to answer. Correct? So how do I get that? This is the question mark, right? How do I get this? So I can raise both of this to some power. For example, I can raise both of them to, I don't know, to 1/3. For example, I can say 17 power X by 3 is 31 power X by 3. All I'm doing is the right hand side and left hand side are being raised to the same power. If it helps me, I can do that. I can raise both of them to the
So
power
won't it
100.
be 31 into 1 by 3 raised to the power 1 by 3, not X by 3?
Oh, yeah, absolutely. You're right. Yeah, good. Abhya is watching keenly. Very nice. Okay, yes, it's 31 power 1 by 3. Yes, 31 power 1 by 3. Similarly, I can do 17 power 100x will be just 31 power 100 if I raise both sides to the power 100. So I can do whatever I want as long as I do it consistently. So in particular, what should I do to make 17 power 1 appear here? I should multiply, the power should be 1 by x. If I raise both sides to the power 1 by 3, we saw it became the first one. Then I said if I raise both sides to become 100, then it became the second one. That proved that I can do something consistently. As long as it happens consistently, it's fine. So I choose to raise both sides to the power 1 by x, so that the x and 1 by x get cancelled. I get 17 power 1 equal to 31 power 1 by x. And that answers my question mark should be 1 by x. Does it make sense? Right? So log of 31 to the base 17, log of 17 to the base 31 is 1 by x. So in other words, to summarize, more generally, if log of a to the base b is c, then log of p to the base a is 1 by c. Okay. So far, so good?
Yes, sir.
Okay. All right. Now, just like in exponentiation, we have a few basic rules, right? For example, if it's 2 power 5 times 2 power 7, we understand it's 2 power 5 plus 7, which is 12, correct?
Yes, sir.
So same thing in logarithms. If I have log of 2 power 12, okay, to the base 2, right? We know the answer is 12, right? We already know the answer is 12, but the 12 can be split as 5 plus 7. And I can write the 5 as log of 2 power 5 to the base 2. Right? And I can write the 7 as log of 2 power 7 to the base 2. Right? Now we would wonder why I would do that. But the thing that it's illustrating is when I add two numbers, so when I add log A plus log b, and I'm not even putting any base here, right? It's true for any base. Okay, fine. Let me put a base c. So when I do log a plus log b, it's log of ab. Okay. So this will be really helpful. So log a plus log b is log of ab. Sumit, all good so far? Make sense? Abhya? Ahan? Ahana,
Yes,
you're
sir.
good? Okay. All right. Now, the next one is, let's say the division rule. In the division rule, what did we study? So we had 3 power 11 divided by 3 power 4 was 3 power 11 minus 4. Right? Because the 3 power 4 got cancelled. So there were 11 threes multiplying in the numerator. There were 4 threes multiplying each other in the denominator. 4 of them got knocked off. The balance was 11 minus 4. That's what happened, right? That was 11 minus 4. The same analogy in logarithms. So I can ask myself, right? Log of, what is log of 3 power 11 by 3 power 4, right? So to the base 3, let's say. So I know this is log of 3 power 7 to the base 3, which is just 7. But I can arrive at the same 7 as 11 minus 4. And I can write the 11 as log of 3 power 11. Don't worry too much about how I'm manipulating this to get this. Just understand like that it's valid. And then later you can prove for yourself, right? So the analogous to thing here is log of a by b is log a minus log b. Okay, I'm putting c here as a general base. Okay, so the sum rule and the difference rule. Log of a plus log of b is log of b. Log of a minus log of b is log of a by b. Okay, now one other last thing you should know is, let me just erase and make some more space. Actually, I didn't need to erase this. It's fine. Okay, fine. Suppose I have 2 power 5 whole power 3. That was 2 power 5 times 3, right? In exponentiation, it became 2 power 5 times 3 because 2, 2, 2, 2, 2. That like that, you have 3 units, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2. So effectively, there's 15 2's multiplying each other. So that is 2 power 15. So what is it in the logarithmic space? It's like multiplication only. So it's saying it's log of, suppose I have to find log of 2 power 5 into 2 power 5 into 2 power 5 to the base 2. By this rule, we are just effectively, it's repeating this like this, right? Except that in the first one, we had just a and b. Now just imagine there's 3 terms, right? Okay, so effectively, what am I saying here? It's 3 times log of 2 power 5 to the base 2. Okay, so summarizing, so if I have log of log of a power m to the base c, okay, I'll put a brackets around this. We are trying to find log of a power m. That's effectively same as m times log of a itself. Right here, I don't need brackets. So the reason I put brackets in the here is, suppose I write log of a, suppose I don't put brackets, then people could interpret it 2 ways. One person might think what I meant, which is log of a power m to the base c. Another person might think, do log of a to the base c and raise that to the power m, right? So this is not what I wanted. This is what I wanted. So to be clear, I put the brackets, right? So log of a power m is m times log a. Okay, so that's the third rule you need to know. And then the last important rule is the change of base rule. So what is the change of base rule? Again, we can easily derive it from the exponentiation rules, but I'll skip the derivation. So it's not that it's difficult. So it's, I'll write it here. I'll write it here, right? So suppose I have log of a to the base b, then that's effectively same as log of a to the base c upon log of b to the base c. This is extremely useful. Why is it useful? For example, suppose I need to find to what power 8 must be raised to get 32, right? 8 power 1 is 8, 8 power 2 is 64. So we know 8 power 1 point something is 32, but can I be more precise without calculator? The answer is yes. If you recognize both 8 and 32 belong to the 2 power family, then I can leverage that. How? Using this change of base. I can say, imagine A is 32 and B is 8. So I introduce my C wisely because I know the connection that links both of them is 2. So I'll write it as by the change of base rule, which I just saw right now, as log of, sorry, what did I write? I wrote nonsense. So log of 8 to the base 2 in the denominator. Ahan, you're with me? What I've written here? Are you able to
Yes.
follow along? Okay.
Yes.
And therefore, this we know. Log of 32 to the base 2 is 5, one of the first questions we asked. And then log of 8 to the base 2 is 2. Sorry, 3. What am I talking? 3. So the answer is 5 by 3. And sure enough, it's a number between 1 and 2, 1.67, whatever, right? So as expected, it's a number between 1 and 2, but we are very precise. It's 5 by 3. Right. And if you look at it, I told you one thing, right? I said log of A to the base B was the reciprocal of log of B to the base A. That's just a special case of this fourth rule. So I'll just give numbers to it. This is the first one, second one, third one. This is the fourth one. So this is just a special case of 4. Why do I say that? Special case of 4. Why do I say that? So I can write log of A to the base B by the change of base rule as log of A by log of B, as long as I can pick some base, right? That's what the change of base rule said. In particular, I can choose that base to be A itself. I can make this A, I can make this A. I have to make it consistent, that's all. In particular, of the infinite choices I have, I can pick the base to be A itself, in which case log A to the base A is 1, because I need to write A to the power 1 to reach 1, to reach A. So it becomes, sorry, what am I? So this is 1 by, right? So this is what we proved, right? Log of A to the base B is the reciprocal of log of B to the base A, right? That's what we proved. I missed the 1 by the reciprocal thing itself here. So, right? So we arrived at the reciprocal thing here now. Does it make sense? What I wrote here earlier was missing the 1 by. That was a crucial thing. Does it make sense, guys? Yeah?
Yes, sir.
Okay, so which is why I can quickly answer. Suppose, all right, let's say Sumair, what is log of 2 to the base 64?
It'll just be 1/2 raised to 6.
1 upon 6.
Sorry, 1/6. Yeah, my bad.
Yeah, 2 raised to 6 is 64. Therefore, log 64 to the base 2 is 6. Yes, and therefore it's 1 upon 6. Okay. All right. So what else do you need to know in terms of logs? You need to know what the domain and range are. Okay, so some of you might have heard these terms, but if not, it's not a big deal at all. It's just, so domain and range. Okay, so in general, what is domain, what is range? Let's take a small digression from logarithms. I'll just take one simple example. Suppose y is a function of x. Suppose y is square root of x minus 7. Okay, now, the value, so y is the independent variable, sorry, y is the dependent variable here. X is the independent variable here. So Ahana, you might not have done functions, right? In ICSE, did you do functions? Okay, but you would have heard of functions, correct? Okay, it's just logical, nothing at all. So it's just all buzzwords. The basic fundamental is very simple only. So it's a function, right? A function or a relation. There's a slight difference between a function and relation, but let's forget that small difference. It's an important difference. But for now, the chapter is not functions and relations. So just to understand, you have some relationship between an independent variable x, which moves around freely, hence independent, and a variable that depends on this, which is why it's dependent variable y. As x moves, y will accordingly move, right? And the way we have written, it looks like x is the independent. Of course, you can always argue that if y moves, then accordingly x must adapt. Yes, they are both dependent on each other. But whenever we write y equal to, if you make y the subject of the formula, then it's called y is the dependent one. The other one is free to roam around, which is independent. So y equal to root of x minus 7. Now, can x take the value 9? Yes, root of 2 is valid. Can x take the value 5? Not valid, because it becomes root of negative 2. Right? You cannot have root of a negative number. Of course, you can. That's a different story. We'll study all about it in complex numbers. Right? You might have heard that, some of you might have come across. So root of minus 1 is defined to be a letter called I in a world called complex world or imaginary numbers or complex numbers. There's a full chapter on complex numbers, which we'll be studying. So that's a separate story. For now, we cannot take square root of negative number. Therefore, we are saying x can be 9, but x cannot be 5. Can x be 7? Yes, because root of 0 is valid. Then if I have to summarize all of it and say, what are the possible values of x? I'll say x can be anything that's greater than or equal to 7. Right? That's called the domain. So defining the set of values that x can take is called the domain. Okay. Likewise, for these set of values that x takes, the independent variable x takes, accordingly, the dependent variable y will move around. So what are the set of values that y will take will form the range. Okay, now, Avya, can you tell me what the range for this will be? Y can take what all values?
Oh. Why? So one sir.
Take your time. No worries.
So y greater than 0?
Y greater than 0. Okay.
Y greater than equal to 0?
Y greater than or equal to 0. Okay, Ahana, you agree or disagree with him?
Okay.
You agree with him? Okay. I'm not saying it's right or wrong. Just one question, Avya. So suppose x is 16. Okay, so I have root of 16 minus 7, which is root of 9. So what is root of 9?
3.
Is it 3 or plus or minus 3?
Oh, plus minus 3. Yes, sir.
So you want to correct your range?
Yes, sir.
So what should the range be?
Can't the range be like all numbers then?
All numbers. So you're correcting
All
yourself
real
to say,
numbers.
so y is all real numbers.
Yes, sir. All
Ahana.
real numbers.
Ahana, do you agree now or you disagree now?
Yeah.
Yeah, what? You agree or disagree? You take a stand.
I agree.
You agree. So earlier you agreed, you agree now also.
Can you give me 1 second?
Okay, take your time. Same question for Ahan and Suman. I'm just calling out these two names. Anyone, it's a small batch, right? Anyone can intervene. Ahan, if you have an opinion, please express. Yeah, Sumair, any idea? Which one is this? So two possibilities, right? So first he thought,
The range, I just think the range is infinite because it can be like,
when you say
Any-
range is infinite, you mean any real number. That's what you mean. When you say range is infinite, for example, y can just be in the restriction 2.1 to 2.3, but there are infinite numbers within that. So it's when you say the range is infinite, it can take infinite set of values between 2.1 and 2.3.
as in like, yeah, any real number.
That's better, right? So you
Yeah.
agree that y can be any real number.
But shouldn't it be greater than 2 to some extent? Because like if it can't, it's like x is greater than equal to 7, right?
Yeah,
So it's below 6. Like if
x is greater than or equal to 7, because if x is less than 7, we get less than,
Yeah.
you get square root of negative number.
values from less than 6, right? So their square roots can't be counted in the range for y.
Wait, we are mixing up x and y now. X, we said 7 or above. If x is less than 7, we get a root of negative number, which is not valid. We are through with x. When
Oh,
it
yeah,
comes to y, I just gave one example. If x is 16, then y is root of 16 minus 7, which is root of 9,
I agree. It's all real numbers.
all real numbers. No, wrong. The first thing was right. Right? What Avya said first, which is y greater than or equal to 0 was right. So what is the mistake? The mistake is root 9, just because I asked stressfully, just because I put emphasis, you said it's plus or minus 3. Saying root 9 is plus or minus 3 is wrong. Whenever we have a square root of a number, it's always the positive root. This is the right one.
So, but
Right.
like, so shouldn't it be minus? Because like, if you inverse it and if it's like minus 3, won't it minus 3 square will also be 9, right?
Good question. So coming to what you're asking, suppose I have a square equal to 9. For this problem, a can have two values. A can be plus 3 or a can be minus 3. However, if I have the question a equal to square root of 9, these two questions are not the same. These two questions are not the same. In this case, a by definition is only the positive 3. The definition of square root is that. Which is why Avya, okay, all of you know the quadratic formula, right? Ax square plus bx plus c equal to 0. Roots kya hote uske? Minus b plus or minus root of b square minus 4ac whole upon 2a, correct? Why did we put the plus or minus? If the root could have meant both plus or minus itself, why do we need a further plus or minus here? The reason we need the plus or minus is because the definition of the root sign is the positive root, or rather non-negative root. Root of 0, 0. So I should say non-negative to be technically right, right? So the definition of root is always the positive root, right? Remember this, guys. So these two are not the same. A square equal to 9 is a quadratic equation which has 2 roots, which is why you have 2 roots, 3 and minus 3. Whereas a equal to root 9 is a linear equation. It has only one root, a equal to 3. In fact, if you set about solving a square equal to 9, you will do it, right? You'll say a square minus 9 equal to 0. You'll write it as a plus b times a minus b. And therefore, you get a equal to 3 or a equal to minus 3, right? Or if you directly write from here, you will say a equal to plus or minus root 9. Root 9 itself is only plus 3, but because there's an extra plus minus outside, it's a is plus or minus 3. Does it make sense? So the root symbol always denotes only the positive root, very important. And therefore, your original assessment was right, that if x is 7 or above, square root of that will always be 0 or above. So the range of values is y is greater than or equal to 0. Okay, so we understand domain, we understand range. Now the same thing, the domain and range can apply to logarithms as well. All of you good on this? Ahan, you're good on this? Whatever we discussed just now, why it's the plus,
Yes.
minus, all that stuff.
So I'll
And-
just be back in like 1 second.
Yeah, sure. Okay. Now let's apply the domain and range concept to logarithms. I'll be sharing the recording here anyway, right? So anyway, that's what I do. After every class, I share the recording because some of the portions you may have gotten a little hazy. I really encourage all of you to go through the recording, right? So that way it'll be much better when you go through a second pass. Now, for logarithms, what is the domain and range? So for this, let's look at an example thing. Suppose I have minus 4 power 3 is minus 64, correct? If I have to write this in terms of logarithms, I'll have to write log of minus 64 to the base minus 4 is 3. Correct? So minus,
So it's wrong.
yeah, it is wrong. Exactly. Yeah. So normally you would have thought that I can write this like this, right? It seems right, right? Minus 4 power 3 is minus 64, but turns out that the definition of log does not allow it. So it does not allow logarithm of negative numbers. Again, we can do logarithm of negative numbers in a complex plane, complex set of complex numbers, that domain, but we'll ignore all of that. For the purpose of this class discussion, log of a negative number is not allowed. Okay, so if I have, okay, however, okay, in fact, let's take a small digression. So what is, guys, let's see, Ahan, what is log of 1 by 7 to the base 7?
Log of 1 by
7 must be, I'll always ask this question. 7 must be raised to what power to make it 1 by 7? Think of it in exponentiation. It's always easier that way. Initially, when you're learning logs.
1 by 7 on like,
Okay, so what is log of 49 to the base 7?
2, right? So 7 by the bottom.
What? Why did he say 2? 2 is right. Why did he say 2? Because 7 power 2 is 49.
Yeah.
Ask yourself the same question. 7 power what is 1 by 7? 7 power what is 1 by 7? Yeah, Hana?
-1.
Yeah, 7 power minus 1, right? 7 power minus. So 7 power minus 3 is 1 by 7 power 3, right? Similarly, 7 power minus 1 is 1 by 7, right? Ahan? So log of 1 by 7 to the base 7 is -1. So we have to be very careful here. The result of taking a logarithm can be a negative number. What is not allowed to be negative is, so for example, if I have log of A to the base B equal to C, right? There are three numbers here, right? That's A, B, and C. Let's look at the restrictions on A, B, and C. Okay. So clearly we said A has to be greater than 0. We also said B has to be greater than 0. Okay. As far as C is concerned, okay, we'll come to that. Okay. Let's see. Sumer. Log of suppose I write log of A to the base B is 0. Is this possible? Can you come up with an A and B where log of A to the base B is 0?
Sure. So the B could be like 7 and A could be 1.
Exactly. So log of 1 to the base 7 is 0, right? Or rather, since we just saw 7, I want to change to some other number. As long as A is 1, the base is 13. 13 power 0 is 1. All right. As long as A is 1, log of 1 to that any base is 0. So we've seen example when C is positive. We have seen example when C is negative. We have seen an example when C is 0. We have seen an example where C is a fraction, like half. We saw that log of 5 to the base 25 is half. We saw that, right? Okay. Can it be a negative fraction? Avya, can you give me an example of A and B where log of A by B is minus 1 by 3? Again, try to convert this problem in terms of exponentiation. It's much easier
Yes,
that
sir.
way.
That's what I'm doing. Sir.
Yeah.
So I can come with like -1, I think.
What is A? What is B? Simple.
But minus. So I can do -1. Let me try -1 by 3.
What do you mean minus 1 by 3?
No, something I can come up with the answers -1. We just did like log.
Yeah, we just did -1, correct. Right, we log 1 to the, so logs 1 by 7 to the base 7 was -1.
Yes, sir. So I'm not sure.
Okay, Ahana, you want to try?
A can be 4, then B would be minus 1 by 64. Sorry, 1 by 64, not minus 1 by 64.
Okay, let's try. Okay, so so she's saying this. Okay, let's verify.
The opposite.
You want to put 1 by 64 here and 4 here. Okay, so she's saying log of 1 by 64 to the base 4. Okay, so is it what you said? Have I written it the way you wanted? Okay, so if what she's saying is right, 4 power minus 1 by 3 should be 1 by 64. Is that right?
Isn't 4 raised to -3 1 by 64 and not -1 by 3?
Exactly. So this is actually 4 power 3, which will be 4 power minus 3. So this is not correct, right, Ahana? But you are on the right track. Just give it one more shot. You agree that this is wrong, correct? Come up with some other A and B, Sumer maybe, or anyone whoever has figured it out. Again, I keep saying, convert this to an exponentiation problem. How do I convert this an exponentiation problem? That means A must be B power minus 1 by 3, correct?
The word log 1 by 2 with the base 8B.
Okay. Log 1 by 2 to the base 8, you're claiming to be minus 1 by 3. Let's check. So if what he's saying is true, then half must be equal to, so this is, I'll put a question mark here since we have not arrived at the conclusion. So this must be 8 power minus 1 by 3. Is it right? So 8 can be written as 2 power 3. So it's 2 power 3 whole power minus 1 by 3. And A power m whole power n is A power mn. So it is this. And indeed, it's 2 power minus 1, which is the 1 by 2 that we want. And therefore, it is right. Well done. How do I come up with this? So how did he come up with this effectively? That's what he did. So let's suppose, right? So I'll convert this. My question was this, right? Log of a to the base b was -1/3. So convert into an exponentiation problem. A equal to b power -1/3. I don't like fractions. Fine. Raise both sides to the power 3 to get rid of the fraction. So a power 3 equal to b power -1 by raising both sides to the power 3. Now the problem is solved. I can pick some a. I'll in fact, just to pick another example, I'll say a is 5. Okay, therefore b power -1 is 125. 5 cubed is 120, and therefore b is 1/125. Right? So here is an example I am coming up with, which is also right. Log of 5 to the base 1/125 is -1/3. His example was also right. Does this make sense, guys? How we can come up? What did he do? He also arrived at a power 3 equal to b power -1. He chose a to be half. And therefore, a cubed was 1/8. And he said, a 1/8 is my b power -1. Therefore, he concluded b is 8, which is how he came up with this example. Right? Maybe he didn't go through the paces, but he did some trial and error and jugad, and he got it. Does this make sense, guys? Okay. Cool. Okay. So where were we? So we have concluded that the result of taking a log, which is the c, can be 0, can be positive, can be negative, can be a fraction positive, can be a fraction negative. So kuch bhi restriction nahi hai, right? For c is bindas. C can be anything, right? And we also said that a and so c is anything. C can be anything. And the way we write formally is c is set of all real numbers. So if you use set notation, it's just looks very sexy, right? Writing like this instead of saying C is anything, it looks cool to write all this and confuse people. Essentially, we are saying C can be any real number, right? So C is any real number. A and B, A is greater than 0, B is greater than 0. Is there any other restriction you think that can apply to A or B? There is, but can you think? Is there any other restriction? Okay, no, I don't want to give away so easily. Okay, think. Yeah. Someone is saying. Yeah.
So one, sir.
Just 1 second. My kids are making noise. I'll just bash them and come. Yeah. Any restriction you think? Okay, let me ask you this question. What is? Yeah.
So does it have to be rational numbers?
Good guess. But let me ask you this question. Okay. What is? Okay.
Oh, but then square root 3. No, then it won't work.
Exactly. In fact, what is log of square root 3 to the base 3?
Yeah.
So my answer, what is this? Log of square root 3 to base 3?
1/2, right?
Exactly. So 3 power half is 1/. So it can be, but good guess, at least for starters, right? What is, can you tell me what is, okay, log 1 to the base 13, we said is 0, correct? What is log 13 to the base 1?
It's not possible.
So it's
It's
not
not, it's not possible, right? What is log 1 to the base 1?
So it could be anything.
possible.
Exactly. So whenever we put 1 as the base, we get into mess, right? We are either saying it can be anything or we're saying it's not possible at all. So to avoid it, people said A better not be equal to 1, right? No, not A, sorry, B, the base. The base better not be equal to 1, right? B can be any positive number other than 1, the base. A can be 1, we just saw log 1 to the base 13 is 0. So these are the restrictions in terms of A, B, and C, right? So if someone asks what is the domain and what is the range, again, depends in the domain. What are you calling? Are you defining it as a function of A or are you defining it as a function of B, right? So C obviously is the Y, the dependent variable. That's very easy. So the range is all real numbers. So this is the range, right? The range is C belongs to real numbers. right? Domain depends whether you're talking in terms of A or whether you're talking in terms of B. For example, if I define log of X to the base root 7 is Y, then the range Y is all numbers. The domain X is all positive numbers, X greater than 0. So the domain would be X greater than 0, strictly greater than 0. X cannot be 0, right? And Y can be all real numbers. Okay. Now, suppose I say log root 27, right? I'm just root 273, some weird number, right? Right? To the base X equal to Y. Then again, range Y can be any real number. The domain X should be any positive number other than 1. So it depends on whether X is the base or X is the number for which you're doing the log for. Is this clear? Ahana, you're with me completely on this?
Yes.
All of us, right? Cool. Okay, so that's logs. I don't want to do logs to death, right? Today was a sample of few different topics, right? What other topics should we do? Trigonometry, all you guys comfortable? Okay, so let's quickly go through some basics of trigonometry, right? So sine, cos, tan, all of you guys know, so I won't bore you, but we have to get started with that, right? So any right angle triangle. So we have, first of all, labeling of triangle is important. So many people get that wrong. So let me cover that. So vertices are named with capital letters. And the sides opposite to them are the corresponding small letters. The word corresponding is important. So A is there. So the small a should go here. B is here. Therefore, small b should go here. The hypotenuse C is small c. Okay. And then if this is theta, then sine, cos, and tan are just ratios of side lengths, right? So sine theta is opposite upon hypotenuse. Cos, I'm just being lazy, I'm just writing as C and T. So you guys know this, right? So cos is adjacent upon hypotenuse and tan is opposite upon adjacent. Okay. Now, basically by doing a square plus b square equal to c square, right? I can start with this. So I'll just call this equation 0, right? I can take this equation 0 and do a few things. I can divide throughout by c square. I can say a square by c square plus b square by c square equal to 1. And just recognize that this is cos square theta and this is sine square theta. Ahana, you have also done trigonometry, right? In ICSE. So that's how we get cos square plus sine square equal to 1. I can alternatively divide the first equation by a square. I can say 1 plus excuse me. And this is tan theta. So 1 plus tan square theta equal to the reciprocal of cos is sec. So sec square theta. And then similarly, I can start with this and divide throughout by b square and write it as a square by b square plus 1 equal to c square by b square. So a by b is the reciprocal of b by a. Therefore, it's cot theta. So cot square theta plus 1. B by c is our sine theta. Okay, I'll just write sine theta so that hardly takes 2 more letters, right? Cos theta and tan theta. Okay, right? So c by b is the reciprocal of sine, which is cosec. So 1 plus cot square theta equal to cosec square theta. That's how we get all 3. Okay.
So sec is like 1 upon cos, right? And cosec is like 1 upon sine, right?
Yes. Yes, exactly. So although they could have labeled it differently, they didn't consult me, unfortunately. So, but yes, so cosec theta is 1 by sine theta. I too had this difficulty in my learning years. So yes, whereas sec is 1 by cos indeed. Okay. Okay. And then the range of values that sine theta can take and cos theta can take is between -1 and 1, right? But you won't see that negative numbers when you're just starting off with a simple right angle triangle. For you, an acute angle is between, have you guys done sine, cos, and tan for angles beyond 90? Ahana, you have done sine, cos, tan beyond 90? Fine, we'll do it. What about you, Sumer? Beyond 90?
No, we've not.
Okay. All right. So we'll do it. In fact, just today itself, we'll do it. Okay. So for now, if an angle is acute, we know sine and cos have to be a fraction between 0 and 1. But technically, sine and cos and any of these for that matter can be negative as well. So sine has to be only numerically less than or equal to 1, meaning it can be a negative fraction as well. So the range of values that sine theta will take is -1 to 1. Similarly, cos theta will also take -1 to 1. We'll come to where we had the negative number and all that, right? And how to interpret it. And tan theta, as far as you were in the first quadrant alone, as in dealing with just acute numbers, tan theta could go all the way till infinity. Tan 89.999 degrees is a zillion or whatever billion, right? But tan 90 is undefined. People say tan 90 is infinity. That's wrong. Don't say infinity, because you will see that, in fact, tan 90 does not even tend towards infinity. There's two things, right? Later in calculus, you'll see something called tending towards, right? So you can say something, so as x tends to infinity, x square also tends to infinity. That's a correct statement, right? If x is approaching, tending to is just approaching, just in layman's terms, it's approaching. As x is approaching 1000, x is approaching infinity, x square is also approaching infinity. That's a true statement. But if theta is approaching 90, it is wrong to say tan theta is approaching infinity. The reason that's wrong is tan 89.99999 will be a zillion. But if you approach 90 from the other side, tan 90.000001 will be a negative zillion. So if you look at tan theta, right? So it'll go up like this, boom, and then it'll come back on this side. So this is 90, right? I mean, this is asymptote. It should not be touching. You understand what I'm talking about, right, guys? Right? So it's an asymptote. You guys know what asymptote is? So where you know the meaning of asymptote? Yeah. Asymptote is a line where you don't touch it, but you approach it. So if you plot tan, it look like this. So this is my 90. So at 90, it's not defined. Fine, it's not defined. Can I even say it's approaching infinity? No, because it's approaching infinity from the left side. Whereas on the right side, if you're approaching it from 90.1, 90.01, 90.001, then it's approaching negative infinity, right? Anyway, so bottom line, tan theta varies from minus infinity to plus infinity, and you never put less than or equal to for any of them. Minus infinity to plus infinity. Accordingly, the reciprocals of them will also vary. So the reciprocal of sine, which is cosec theta, right, will be greater than 1 or less than minus 1. Greater than equal to 1, sorry. Greater than equal to 1 or less than or equal to minus 1. Similarly, sec theta also same thing. Same. Right? And cot theta is the reciprocal of tan. So cot and tan are exactly same. Both vary from minus infinity to plus infinity. Okay. But first, let's understand angles beyond 90. When do we get this negative values for sine, cos, and tan? Because looks like other than Avia, none of you guys have done this negative values for sine, cos, and tan. Okay. So for this, how do I draw a right angle triangle with an obtuse angle like 95 degrees? It's impossible, right? So we have to get out of the mindset that trigonometry is only for right angle triangles. That's a start. Trigonometry, you start by introducing acute angle, right angle triangles where the angles are acute, right? Other than the 90, the other two angles are acute. But if you think of sine theta as opposite over hypotenuse, then it's forcing you to think of a right angle triangle where the angles are acute, right? But if I have to think sine 120, how do I visualize cos 150, sine 120, tan 265? How do I visualize all that? So for that, let's draw some grid line, right? So is that tools? Okay, and then I'll do more here. This grid line sometimes I don't draw a line. I'll just draw a line using. Okay, so these are the 4 quadrants. Okay, so the labeling of the quadrants, just to be sure we are all on the same page. This is quadrant 1, which is where we start. Oh, I didn't switch. Okay, so this is quadrant 1, which is where we start. This is quadrant 2. This is quadrant 3, and this is quadrant 4. Okay, so in the first quadrant, everything is positive. sine cos. First, I'll give you what is positive and what is negative and all that. So A for all, right? All are positive. Right, in the second quadrant, sine alone is positive. When I say sine alone, I obviously mean the reciprocal of sine, which is cosec. Cosec is also positive. And then in the third quadrant, tan alone is positive. When I say tan alone, I mean cot as well implicitly. And then similarly, the fourth quadrant, cos and its reciprocal sec are positive. So way people remember, this is some acronym ASTC, right? So
this cost diagram, right? We've done this.
you've done this? Okay, fine. Maybe it's just a quick recap. I'll just go fast then, right? ASTC, you guys know, right? What did he say, Sumer? I didn't hear that fully. What diagram?
This is a cost diagram.
I don't know what cost diagram is. COS?
CST.
Okay, cast. Okay, just to see. Okay, you're counting from the C here at the top, at the bottom, and then say CAST. Okay, I like to go from the order from first quadrant. So A and then S and then T and then C. Effectively the same thing, right? There are four things: ASTC. However way you want to start and remember, that's fine. So ASTC. That's probably what you meant as well, right? Sumer?
Yes, sir. So
Okay.
that's right.
Okay, all right. So I'll just erase this to make space. So ASTC. But why do we get that in each quadrant? Something is positive and something is negative and all that. Why do we get that? So how do we think about sine and cos in the second quadrant and third quadrant? If there's we cannot even visualize a right angle triangle with 120 degrees. How do we do that? The way we do that is not by right angle triangle, but by just thinking in terms of a line. Okay, so I'll draw a line from origin, okay, to this. Okay, now this line can be here. This line can be here. Okay, this line can be in the third quadrant somewhere. This line can be in the fourth quadrant somewhere, and it can be of different lengths also. So I'll change my definition of sine and cos to adapt to all quadrants. So the way I define sine and cos now is, okay, forget the ASTC for now. They're distracting. We'll infer that indeed sine is positive here, and we'll infer that ourselves rather than being told that's the case. So the way we'll define sine theta is, I have to keep swapping. That's the pain in this. Okay, all right. So the way we define sine theta is not by right angle triangle, but by saying the vertical projection. I'll define what this means is vertical projection upon the length of the rod. Okay. It's very clumsy definition, but the formal textbook would have a proper definition. What I mean is important. So imagine this is a rod. This has a certain length, right? Let's say the length of this is 3 meters. Okay. Now just imagine there's light source everywhere at infinity, minus infinity, upar se, niche se, everywhere, right? Where will the shadow of this guy fall? In the y-axis, it'll fall here, right? The shadow will fall here, correct? So the length of that shadow on the y-axis is this, right? So you can think of sine as the vertical projection, as in projection on the y-axis upon the length of the rod. So let's say this happens to be 1.6 meters. Then you can say sine theta is 1.6 upon 3. The length of the rod will always be a positive quantity. So the denominator will always be positive. The numerator, you will see, could be positive or negative. So let's define cos theta also. So cos theta is the horizontal projection upon the rod length. So later we'll just avoid the denominator by saying the rod length is 1. We'll keep a unit rod, which is why you'll say unit circle. You might have heard the term unit circle. Namely, the rod length is 1. Because why bother with the denominator? If you can make it 1, it's convenient, right? So just look at the vertical projection or the horizontal projection. But for now, just to understand, I'll make it not 1, right? So cos theta is the horizontal projection upon this. So in the first quadrant, this was 1.6, and maybe this is the horizontal projection because the reflection of this will fall here. So maybe this was, I don't know, 2.7, right? Whatever, 2.7 square plus 1.6 square may not be 3 square, but for now, just go with the flow, right? In that case, the cos theta would be 2.7 upon 3. right? Now, if I come to the second quadrant, and let's say in the second quadrant, let's say I make the length of the rod 2.8 meters. So it's slightly less than 3, right? So the X projection and the Y projection will be different. So let's say this length is 1.2. So my sine theta, so let's say this is my, in fact, I want to focus on the second. So this is my theta. This obtuse angle is my theta, not obtuse. This angle which is more than 90, right? Right. This sine theta is 1.2 upon 2.8, still a positive quantity. Whereas cos theta, you'll see is negative, because let's say this length, the reflection falls here, right? So the vertical projection falls here. Let's say this is minus 2.2. So this is minus 2.2 comma 0. So cos theta is negative 2.2 upon 2.8. Right? Or rather, I should put it in this quadrant so that it's not confusing. So I'll just put cos theta is minus 2.2 upon 2.8. So cos is negative, whereas sine is still positive. Right? You can feel that in the second quadrant, the projection on the y-axis will be on the positive y-axis, which is why the sine will always be positive. The sine, SIN sine will be positive. Whereas the cosine, right? The projection on the x-axis, the horizontal projection, right? Therefore, always for cos, the projection is on the x-axis, horizontal. The projection is on the negative x-axis, which is why cos will always be negative in the second quadrant. Does it make sense? In the I'll skip third quadrant for a second. I'll come to the fourth quadrant. So same thing, right? I can make a length of the rod anything, right? So let's say this is 1.5 is the length of the rod. You can see that cos is now positive because this length is on the positive x-axis. Let's say this is 1.1. So cos of alpha, what is my alpha? This is my alpha, this big reflex angle. So cos of alpha is 1.1 upon 1.5, whereas sine of alpha is, let's say this is 1.2 negative. So sine of alpha is negative 1.2 upon 1.5. Does it make sense? So sine is negative here, whereas cos is positive. And you can see that, right? So sine is positive here because the vertical projection is positive. Of course, in the first quadrant, both the vertical and horizontal are positive. Therefore, everything was positive. In the fourth quadrant, the projection on the x-axis was positive, which is why C was positive. Whereas in the third quadrant, both sine and cos had projections which are negative. The reflection of the line in the third quadrant, which is this guy, right, fell here, right? So fell, sorry, this is very blurry, so I'll just change colors. So the negative, the projection here was negative. The projection here was also negative. Both sine and cos were therefore negative, but tan, I didn't define tan. Tan is just reciprocal. No, tan is the ratio of sine and cos. Therefore, when both of them are positive or both of them are negative, tan becomes positive. So tan became positive here. Whereas in the second quadrant and the fourth quadrant, when only one of them was positive, the other one was negative, tan was also negative. So this is first, this is second, this is third, and this is fourth. You guys understand now, right? How the positivity and negativity comes from. Did you know this as well, Subair, as part of your CAST, or this is new?
No, sir. So we didn't know the reasoning behind why.
Okay, does it make sense now?
Yes, sir.
All of you good? Ahana, you good? Okay, now, how do we, so knowing the sine, cos, and tan in the first quadrant, you can figure out sine, cos, and tan in any quadrant very easily. Okay, so first, but we should know the sine, cos, and tan in the first quadrant, just to be very clear. And let's quickly recap. So if I have theta, and this is sine theta, cos theta, and tan theta, basic angles we should know, right? Which are 0, 30, 45, 60, and 90. Okay, so sine 0 is 0. Sine 90 is 1. You can just visualize an extreme case of a flat right angle triangle or a steep right angle triangle. So this is like a flat right angle triangle, right? So just imagine this is 0 degrees. The opposite side is almost 0 compared to the hypotenuse. Whereas if you have a steep right angle triangle, the opposite side is almost same as the hypotenuse. So sine 0 is 1, cos 9. So similarly, the cos will be reversed, right? 1 and 0 here. Sine 30 is half, right? And so is cos 60. And sine 60 is root 3 by 2. And so is cos 30. You guys all know this, I'm sure, right? 1 by root 2, 1 by root 2. All of you good on this? Sumer, Ahan?
Yes, sir.
Yes.
All of this, okay, because, okay. So 30, 60, 90 is a very important triangle. So if I have a 30 degree, 60 degree, 90 degree, it appears like over and over in multiple places, right? So if I have a 30, 60, 90, if this is 30 degrees, if this is 60 degrees, then the ratio of the sides will be, let's say this is A, then this will be A root 3, and this will be 2A. So the ratio of sides in a 30, 60, 90 is 1 is to root 3 is to 2, which is how you get this 1 by 2 and root 3 by 2 and all that for sine 30 and cos 30. Similarly, for a 45, 45, 90, it makes things very easy because it's isosceles as well as right. So it's this. Therefore, if this is A, this will be A root 2. Right, which is why tan 45 is 1, right? And the sine and cos are 1 by root 2 each. Okay, so tan is just reciprocal, which is easy to fill. 1 by root 3, and this is not defined. NA, not defined or not defined. No, don't say infinity, please. Okay, so all these we know, and of course there are ways to figure out what sine 15 is, what sine 75 is. Have you guys done sine of A plus B, cos of A plus B, all that? Ahana, have you done it? Sine of A plus B, cos of A plus B, all that? We'll review that as well. If no, we have not done. Okay, we'll do that. Okay, so there are ways to find out sine and cos of, and of course tan also, of some of these angles. So for example, we can do a sine of, again, we'll do at length, but just to illustrate one thing, right? So there is a formula for sine of A plus B. Avya, do you know? Can you recall for class? What is sine of A plus B?
No, so we haven't done this formula.
You have not done this? Okay, all right, I'll give it to you right now here, right? So sine of A plus B is sine A cos B plus cos A sine B, right? And similarly, we can do sine of A minus B, we can do cos of A plus B, cos of A minus B, tan of A plus B, tan of A minus B, all of that, fairly easy to figure out all of them. If you know like one, you can figure out the others. At least you just need to know 2 of them. Okay, we'll come to that in a while. Okay, but just knowing this, my point is I can find out what sine 75 is, for example. Why? Because in fact, can you find sine 75 given this information? I can write for 75 as 45 plus 30 and find sine 75 for me. Can you guys work it out? Yeah, anyone? Sumer, you have an answer? Ahana, you have an answer?
I got root 2 plus root 6 the whole upon 4.
Root 2 plus root 6 whole upon 4. Yeah, okay. So Ahana's answer is root 2 plus root 6 whole upon 4. Let's check. Okay. All right. So sine of, I'll just write it as sine 45 cos 30. So sine 45 is 1 by root 2. Cos 30 is root 3 by 2. Plus cos 45 is 1 by root 2. Sine 30 is 1 by 2. So the denominator is 2 root 2. And numerator is root 3 plus 1. And she has multiplied by root 2 to save the denominator having irrational numbers from having irrational numbers by multiplying by root 2. Indeed, this becomes root 6 plus root 2. Well done. Okay. And approximately, we can, if you just have to hand calculate, what is root 2 approximately, guys? 1.4, 1.414. You should know this. Root 2 is easy. What is root 6? I have to guess root 6 without calculator.
So maybe like 2.4.
So
Very good.
2.3, yeah.
Yeah, 23 square is 5. So perfect squares will help here. 24 square is 576. 25 square is 625. So 600 square is somewhere in between 24 and 25. So which is why 2.45 approximately. Again, you don't have to kill yourself. 2.4 is good enough for a first guess, right? Just to get some sanity check. That's all. Approximately this. So 3. Just want to make sure it's less than 1. but we also want to make sure it's close to 1 because sine 90 is 1. It better be some number close to 0.9 or 0.95, and so it is, right? Similarly, there are formulas for cos of a plus b, cos of a minus b, and all that. Okay, so let me just give you one more. Okay, so in fact, I can finish off in this itself. So I can say if sine of a plus b is this, and just by putting a negative sign, I can write a formula for sine of a minus b. The only thing that will change is the negative sign. So sine of a minus b is sine a cos b minus cos a sine b. As simple as that. So if I have to do sine 15 by the same logic, it'll be just very similar. It'll become root 3.
You lagged a little bit. So what do you say?
Okay, when I put a negative sign, it's sine of a minus b. The right hand side also takes a negative sign in beach mein. So sine a cos b minus cos a sine b. Therefore, sine of 15 by the same logic will work out to root 3 minus 1 by 2 root 2. Okay, and interesting thing is this will be cos of 75 because sine 15 is cos 75. Okay, and let's verify now that if something is wrong, then sine square 75 plus cos square 75 should be 1, right? So let's verify. So we are saying this is sine 75. We are saying this expression is sine 15 and therefore cos 75 because sine theta is cos 90 minus theta. Let's verify. If I square and add these two quantities, do I get 1? So let's do root 3 plus 1 whole square plus root 3 minus 1 whole square upon 2 root 2 whole square. So what is numerator? A plus b whole square, a square minus 2a plus 2ab plus b square. A minus b whole square is this, right? The 2 root 3 gets cancelled. 2 root 2 is square is 8. And sure enough, 3 plus 1 plus 3 plus 1 is 8. We get our sine square theta plus cos square theta as 1. So we have verified that sine square 75 plus cos square 75 is 1. Okay, so let's do one more, right? So I'll give the formula for tan of a plus b. So tan, I didn't give you for cos yet. I'll give you, no problem. So tan of a plus b is tan a plus tan b. I'm just being lazy. I'm just writing t by 1 minus tan a tan b. Okay, and then if I have to do tan of a minus b, just follow the red. The signs switch in both, but you have to be consistent. Upar ka upar, niche ka niche. So tan of a minus b is tan a minus tan b upon 1 plus tan a tan b. You guys good with me on this? Okay, so therefore, in particular, again, I'm going at a rushed pace, but I just want to give a flavor of different things, right? In particular, you can arrive at double angle identities. What do I mean by that? I can arrive at tan of 2 theta. Because if I put a and b as both theta, then it becomes tan theta plus tan theta in the numerator, which becomes 2 tan theta upon 1 minus tan theta tan theta. So 1 minus tan square theta. Are you guys following along? If a and b are both theta, then tan of 2 theta becomes 2 tan theta by 1 minus tan square theta.
Yes, sir.
Okay, so can you find tan of 22.5 degrees using double angle? Try to be creative. Hint, you'll need quadratics, which you have done. Any idea, Avya?
No, so I'm trying to figure it out.
Ahan, what about you?
No, sir, same.
So could we use 45 and like divided by 2?
Exactly, yes. So set theta to be 22.5. 2 theta is tan 45, which you know is 1. And therefore, you get a quadratic in terms of tan 22.5. Yeah, that's right. Can you all do it now?
So but won't it like, you said the signs will switch, so won't it like not work? Like won't the denominator become 0 then?
Why?
I mean,
Theta is 22.5. Theta is not 45. If you're trying to do tan 90, then theta would be 45 and the denominator would be 0, which is why it's meaningless. But I'm saying theta is 22.5, 2 theta is 45. So you know tan 2 theta, but you don't know tan theta. Are you with me?
Right. Yes, sir.
So just to be clear, I'll say let I'll say let theta equal to 22.5. Therefore, tan theta, okay, tan theta equal to tan 22.5. Okay, don't you take all the shortcuts, write it as tan. I'm just being lazy here. So we know, okay, let me quickly do it. I'm almost up on time anyway. Let's quickly discuss this, right? So we know tan 2 theta is this expression that we gave. So tan of 2 times 22.5, right, is tan of 2 theta, right? So we know that is tan of 45 equal to 1, right? So we know on this one, we know the left-hand side. So we are trying to find tan theta. So we know the left-hand side is tan 45, which is 1. So the right-hand side is, I'll just call tan theta as something like x or something, right? So I'm right. So 2x by 1 minus x square. My question is to find x. Tan 22.5 is what I want, correct? Multiply, get a quadratic, solve. So 1 minus x square equal to 2x. Let's get everything to the right side. X square plus 2x minus 1 equal to 0. Let's apply the quadratic formula. Ahan, can you recap for me the quadratic? Ax square plus bx plus ki roots kya hote hain? Minus b, plus or minus?
So yes, so the rules.
Yeah, go ahead. Ahan, roots of ax square plus bx plus c equal to 0 are minus b.
Yes, so minus b plus minus root b square minus 4ac.
Exactly. So minus 4 into 1 into minus 1 whole upon 2a,
Yes.
right? Which is this. So it's minus 2 plus or minus root of 8 whole upon 2, right? Obviously, root 8 is bigger than 2. Therefore, we know that tan 22.5 is positive, right? So it's minus 2 plus root 8 upon 2. But of course, I can write root 8 as 2 root 2. Right? So effectively, it's root 2 minus 1 plus root 2. Minus 1 plus root 2.
So I don't know how to like simplify these roots. Like if it's root 16, I don't know how to simplify it into something like
Root 16 is 4 by itself.
So that's 4.
Right? But if I have, okay, fine, maybe root 32, it's root of 16 into 2, right? So which is root 16 into root 2, which is 4 root 2. As simple as that. Yeah.
Yes, sir.
Okay, so root 2 minus 1, which is approximately 1.4 minus 1, which is 0.4. And does it roughly make sense? It does, because tan 30 is 1 by root. I don't expect you to know all this, but just at least get into habit of estimating rough numbers, right? 1 by root 3. What is 1 by root 3? Root 3 upon 3. What is root 3? 1.732. At least 1.7. That much you should know. So 1.7 by 3 is approximately 0.6. Right? And sure enough, tan is an increasing function. As theta increases, tan increases very steeply. So it's fair to believe that tan 22.5 is 0.4 if tan 30 is 0.6. Right? It's not grossly off. If you get 0.65 or 0.7, you should wonder why. Right? Does it make sense? Okay, let's stop here. I wanted to do like one more topic, quadratics maybe, but anyway, you have done quadratics, at least the basics of it. So we did trigonometry a bit, we did logarithms a bit. Again, all of these are extensive chapters by itself, by themselves, but today was just a sample from each of them. Okay. All right, I'll be in touch with your parents. I know different people have different vacation schedules. That's what makes it a little challenging. Not everyone is around the same time. So yeah, I'll be discussing and even the time slots, like on weekends, which months we should meet, considering my other classes as well. So yeah, we'll discuss more with the parents and then get back. Okay, but this is the pace I'll be going at. Right, this is cool. This pace is cool. Avya, you're okay with this?
Yes, sir. So good.
Ahana?
I just want, so sometimes like if there's like a topic that we don't know, like if when you write something, that's when I just want you to go a little slow.
Sure. Yeah. So the batch size will be fairly small. By small, I don't mean this small. It'll be typically between 7 to 10 kids. Sometimes it's like max I'm saying is 10 kids, right? So you will have a lot of focus, no worries at all. What I want you guys to do is bold enough to say, no, sir, I did not understand. There's no shame in that at all, right? So I was very notorious and popular / unpopular for asking a lot of questions. And my friends came and thanked me because I was brave enough to admit that I didn't know. So please, there's no shame at all. Call out something that's not clear. The sooner we fix it, the better, right? Don't think you're doing yourself a favor by pretending that you understood, which is why I need all the cameras on. I can read from your face if you got it or not, right? The face will tell you, right? I've been in this business for all too long now, right? So you cannot hide it, and you should not even hide it, right? You're not helping anyone by saying you understood when you did not. Okay. So yes, Arya, to answer your.
So sorry, is it possible we can just scroll up? I just forgot to like note down one of the formulas.
Yeah, you can do that. But also that brings to the second part. The entire session will be recorded and shared after class. So go through it, not just the notes, but also hear it and try to do yourself, whatever we did, all of that. So watch the recording. And also I'll be purging the recordings after every 2 weeks. Did I get the formula, or did I go up, or which one did you want? Okay, so yeah, and then save down a copy of the recording, because with so many classes, I'll be purging them quickly after every 2 weeks or so. So or max 3 weeks, I'll retain. Okay, so save a local copy so that you can be independently referring to it whenever needed. Okay, all right then. Chalo, have a good night.
Thank you, sir.
Bye.
Thank you.
Bye.